Okay, so I'm just going to run through the trig identities and just give you a quick little way to remember them. There's a couple of different ways of remembering them. We're just going to derive it first. So if we look at the unit circle, so unit circle means it has a radius of 1, and we call this x and y and theta. Now we know by Pythagoras that x squared plus y squared equals 1. So if we look at cos theta is x on 1, so x equals cos theta. And sine theta is y on 1, so y equals sine theta. So if you put this into x squared plus y squared, just to clarify that too, sine is opposite on hypotenuse, that's why it's y on 1. And cos, how do you get x over 1? Well, that's adjacent on hypotenuse, that's why it's x on 1. So we know x equals cos theta and y equals sine theta in that triangle. So then if we put it into x squared plus y squared equals 1, x is equal to cos theta, so it's cos squared, plus y, which is equal to sine theta. So that means cos squared plus sine squared equals 1. And this is one of the trigonometric identities. Now, from this trig identity, we can derive some other ones. So we've got sine squared plus cos squared theta equals 1. So if we divide this by cos theta, so it divides cos squared theta, if we divide everything by cos squared theta, then sine squared on cos squared is tan squared, cos squared on cos squared is 1, and 1 on cos squared is sec squared. So that's another identity that we can use. And if we take the original one, so sine squared theta plus cos squared theta equals 1, and we now divide that by sine squared theta. Sine squared theta. Sine squared theta on sine squared theta is 1. Cos squared theta on sine squared theta is cot squared theta. And 1 on sine squared theta is cosec squared theta. Because the third letter rule, cosec is the reciprocal of sine, and the third letter rule, that's cot, is the reciprocal of tan, and tan is equal to sine on cos, and cot is equal to cos on sine. So we have 3 trig identities that become quite useful throughout these higher mathematical courses. So we've got sine squared plus cos squared equals 1, and from that it's really good to be able to just rearrange this. Well, sine squared theta is 1 minus cos squared theta, and also if you rearrange it and bring the sine squared to the other side, cos squared is 1 minus sine squared theta. Okay. The other thing is we've got sec squared theta equals 1 plus tan squared theta. And you can also rearrange that, because you can also get sec squared theta minus 1 equals tan squared theta, or sec squared theta minus tan squared theta equals 1. So it's always good to be aware of the rearrangements of these as well. And the same, you've got cosec squared theta is 1 plus cot squared theta. And you can rearrange this one to get cosec squared theta minus 1 equals cot squared theta. And cosec squared theta minus cot squared theta equals 1. That's the other one as well. So you have sine squared plus cos squared is 1. These are your major ones. Sec squared is 1 plus tan squared. And cosec squared is 1 plus cot squared. Now from this, you have to think, you can try and think of ways to actually remember it. But if you've got your original one, sine squared theta plus cos squared theta equals 1, which is on your formula sheet, if you want to get sec squared theta equals 1 plus tan squared theta, you can either learn it off by heart, or you can just divide everything by cos squared theta. Cosec squared theta equals 1 plus cot squared theta. So you could just divide everything by sine squared theta to get that one. Okay, now, so you got your 3 of them. And so that's 1, 2, 3. You could also, there's a way of remembering it by using this 3-leaf clover thing like this. So you go, sorry, the 4-leaf clover. We'll get rid of that one. 3-leaf. Like that. So you go sine squared theta, cos squared theta. You start with that. The reciprocal of sine squared is cosec squared theta, and the reciprocal of cos squared theta is sec squared theta. And then you just put tan squared theta here, and on this side you put the reciprocal, which is cot squared theta. So in order to use this as a memory hook, this is 1 in the middle. So if you trace along the lines, and I just realised that basically the part that you join up isn't this one here at all. It is going to be, you join this one up, and this one up. And they're all connected. Okay, so if I did sine squared plus cos squared, that will equal 1, or cos squared plus sine squared is 1. So going down is like in the positive direction. So if you look at, come here, you got tan squared, so that's the positive direction. Like that's just going across, but I'm going to go sine squared plus 1 equals sec squared. And 1 plus tan squared, sec squared. So 1 plus cot squared is cosec squared. Now, if you went backwards on these, so have a think about this. So you go sec squared, if you're going backwards, that's minus. So sec squared minus tan squared is 1. Sec squared minus 1 is tan squared. See how I'm going backwards. Cosec minus cot squared is 1. Cosec squared minus 1 is cot squared. If I was at 1, 1 minus cos squared is sine squared. 1 minus sine squared is cos squared. But in some ways, I think it's easier if you just got to really put these to memory. Cos squared is 1 minus sine squared. Like that needs to be automatic. Sine squared is 1 minus cos squared. And another one that frequently comes up is sec squared theta minus 1 is tan squared theta. I think they're really, really important. And just your proper identity, like your original identity, not your proper one, but your original one really needs to be put to memory. And then sec squared theta is just 1 plus tan squared theta, and cosec squared theta equals 1 plus cot squared theta. Think of the two C's. The C's always go together in trigonometry. And think of CC chips. And think of, you've got a tan there, and think of sec squared with a tan. So you've got,